Hello there guys, welcome back to another epic inexorable maths video. In this video we're looking again at arithmetic series and we've got some more questions for you. So if you've not seen the first video, go and check that out, link is in the description. This is going to be a continuation of that video. So we want to find the sum of the first 20 terms of the arithmetic series 3 plus 7 plus 11 plus 15 all the way up to whatever the 20th term is. So how are we going to do that? Well, we just need to use this formula, which we derived in the last video, and we simply identify what is A, what is D, and what is N, and we literally plug in. So the sum of the first 20 terms is going to be 20 over 2 times 2 lots of the first term, which is 3, plus n minus 1 lots of the common difference. So n is 20, so n minus 1 is 19. And the common difference this time is positive 4, because you have to add 4 to get to the next term. So timesing that by 4. Okay, simplifying this, 20 divided by 2 is 10. 2 times 3 is obviously 6. And 19 times 4 would be 76. Okay, and this is 10 times, or 6 plus 76 is going to be 82. So 10 times 82 is 820. And that is going to be our answer. So really guys, all these questions are a basic application of that formula right there in yellow. It's really, really that simple. But let's do another example nonetheless. So this time we want to find the value of 4 plus 7 plus 10 all the way up to 91. So the first thing that we have to notice about this is they don't actually tell us what n is. So this will be a slightly harder question. They don't say what n is. And also they don't technically say that it's an arithmetic series. But we should check that it is. We can see that it is because the difference between 4 and 7 is 3. The difference between 7 and 10 is 3. So we can we can suitably assume that this is an arithmetic series. But the problem is we don't know what n is. So what do we plug in for n? Because we can't just go straight into this formula right now. So there are two things that we can do. First of all, let's just find what n is. And then I'm going to tell you something that you might find helpful. There's an alternate version of this formula that we could use here. Okay, so the first thing that we should do is find n. How do we find the value of n? Well, guys, if you remember arithmetic sequences, how do you find the nth term? Well, there's a formula for that. So I know that un is a plus n minus 1d. Okay, so I'm going to kind of rearrange this a little bit, and I'm going to let un equal the last term, which is 91. So I'm going to say that 91 is the first term, which is 4, plus, and I don't know what n is, so it's going to be n minus 1, and then d is 3. So I'm going to write it like this, and then I can solve for n, and it will tell me which term 91 is. It will say 91 is the whatever term. So if we rearrange, we can do this however we want, but 91 equals 4 plus, and then let's expand these brackets out. We're going to have 3n minus 3. 4 minus 3 is 1, so 91 equals 1 plus 3n. That means that 90 is 3n, which means that n is 90 divided by 3, which is 30. So that's telling us that 91 is the 30th term, so we are going to find the sum of the first 30 terms of this series, okay? So the sum of the first 30 terms is going to be 30 over 2 times 2 lots of the first term, which is 4, plus 29, because that's n minus 1, times the common difference, which is 3. Okay, so what have we got here? 30 divided by 2 is 15. 4 times 2 is 8. And 29 times 3 is going to be 87, right? Yeah, 87. Yeah, mental maths. Okay, and then we've got 15 times, and then 8 plus 87 is 95. I don't know what that is off the top of my head, so I'm going to go and check my notes, see what that number is. We have got that 15 times 95 is going to be 1,425. 1,425. Amazing. Okay, so that is the sum of the first 30 terms. That is the value of this. And again, it really is that simple. Now, I said that I was going to tell you something that you might want to know. So if we look at the formula for an arithmetic series for 1 second, I'm just going to make some space over here, get rid of this. We can see that there is an alternate way to write the formula. Honestly, it's rarely that helpful, but it's good to see because you may need to know it. If we rearrange this, and I'll do it over here for a second. If I rearrange this, well, not even a rearrangement, but let's just split the 2a into a plus a. We're going to have a plus a, then plus n minus 1d. Okay, but guys, this a plus n minus 1d is the nth term. So it's the last term of whatever we're trying to add up. So you can write Sn as n over 2 times a plus the last term. So the first term plus the last term, which some people write as L, and some people might write this formula as U1 plus UN. Again, it's just the first term plus the last term. So some people use this notation. U1, that means the first term. UN means the last term. Some people use this notation. Some people use this notation. But either way, it's good to know that Sn can also be written as n over 2 plus the first term plus the last term. Now again, it's not that useful because you do still need to know what n is because n is still in the formula. So it wouldn't have helped us tremendously with this question, but sometimes it can simplify the working out because whilst we're doing all of this stuff, you don't necessarily need to compute all of this. This number here is just going to be 91 in this question. So it can save you a few seconds if you prefer to use that. If you know what the last term is, you don't always know. This is the first question that we've done where we actually did know what it was, but this is here if you need it. So guys, thank you so much for watching. As always, I hope you found that helpful. If you have any questions, please leave them in the comment section below, and I'll see you in the next video. Cheers.